In today's lecture, we are going to see the sum to n terms of an AP. So let us denote the sum to n terms by Sn. Then the sum to n terms will be first term plus second term plus dot 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 plus last second term an minus 1 and the last term an. So if we write this in terms of a and d, then Sn will be equals to a1 is a plus a2 is a plus d plus dot 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 an will be a plus n minus 2 into d plus an is a plus n minus 1 into d. The same sum to n terms, if we reverse this, what happens is the last term we'll write as the first term, last second as the second. Similarly, we'll write the second as the last second and the first as the last term. So Sn, on just inverting this, what we get is a plus n minus 1 into d plus a plus n minus 2 into d plus dot 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 plus a plus d plus a. So let's take the sum of these two terms. So Sn plus Sn becomes 2Sn. We are adding these two equations. This is equals to a plus a becomes 2a plus n minus 1 into d plus a plus a is 2a plus n minus 2 into d plus d will become n minus 2 plus 1, that is n minus 1 into d plus dot 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 plus again 2a plus n minus 1 into d and again 2a plus n minus 1 into d. So total of how many times we have, there were n terms. So when we add all of this, this whole will also be total of n times. So this implies 2Sn is equals to n times of 2a plus n minus 1 into d. So this implies Sn equals to 2 comes to the other side in division, 2a plus n minus 1 into d. So this is our formula for sum to n terms. This can also be represented in this way, where we write n by 2. 2a we are dividing as a plus n minus 1 into d. So this one becomes a plus n minus 1 into d is an. So n by 2 we get a plus an. So Sn can also be written as n by 2 a plus an. That is the first term plus last term. So these two formulas we have for the sum till n terms of an AP. Okay. So now let's solve some questions relating them. Example 1. Find the sum of the first 22 terms of the AP 8, 3, minus 2, dot dot dot. So solution here. The first term is 8 and the common difference will be some difference of consecutive terms. So 3 minus 8, that is equals to minus 5. And the number of terms we need to find is 22. So we know Sn equals to n by 2, 2a plus n minus 1 into d. Since we have a, n and d, so we are using the first formula. So this implies sum till we need to find 22 terms. So S22, the sum till 22 terms is 22 by 2. 2 into A is 8 plus n minus 1, that is 22 minus 1 into D is minus 5. It is equals to 11 into 16 plus into minus becomes minus. This is 21 into 5. This is 11. 60 minus, this is 105. So 11 into, this becomes 89 minus 89. So we have minus of 89 into 11 will become 979. So the sum of 22 terms of the AP becomes 979 minus 979. Okay, second example. If the sum of first 14 terms of an AP is 1050 and its first term is 10, find the 20th term. So solution, here we are given that number of terms is 14, the sum till 14 terms is 1050 and the first term A is 10. So A is 10, number of terms is 14 and the sum till 14 terms is 1050. So these three are values that are given to us. So we know Sn equals to n by 2 2a plus n minus 1 into d. So this implies sum till 14 terms will be equals to 14 by 2. 2 into a is our 10 plus 14 minus 1 into d. So the one value that we do not have is of d. This implies 1050 is equals to 2 ones are 2 7 is equals to 7 into 2 10 20 plus 13 d. This implies, I think this will cancel out, so 1050 by 7 equals to 20 plus 13 d. 7 ones are 7 ones are 7, we have 35, 7 fives are 35 and 0. So 150, 20 comes this side, minus 20 equals to 13d, or 13d equals to 130, which implies d equals to 130 by 13, that is equals to 10. So the common difference we got is 10. What we needed to find was the 20th term. So A20, the 20th term will become equals to a plus 20 minus 1 into d, which is equals to a is 10 plus 19 into 10. 1910, 190 plus 10 is 200. So our 20th term is 200. Next example 3. How many terms of the AP comma 21, comma 18, comma dot 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 must be taken so that their sum is 78. So solution. Here given to us A, the first term is 24. The common difference is 21 minus 24, that is minus 3. The sum till n terms must be 78. So what we need to find is we need to find the number of terms n. So we know Sn equals to n by 2, 2a plus n minus 1 into d. This implies 78 equals to n by 2, 2 into 24 plus n minus 1 into minus 3, which implies 2 comes over here. 78 into 2 equals to n. Here we have 48, plus into minus becomes minus 3n, minus minus plus 3, which implies 8 to 16, 7 to 14 plus 1, 15 equals to n into 48 plus 3, 51 minus 3n. This implies 156 equals to, we can take 3 common over here. So we are taking 3 common. We are left with 3 ones are 3, 21, 3 sevens 21, n goes inside, 17n, minus 3 came outside and n is going inside, so n square. So 3 comes in division, 156 by 3 equals to 17n minus n square. 3 ones are 3 fives are 15, 3 twos are 6. So we bring everything to the left hand side, minus n square comes here, plus n square, minus 17n plus 52 equals to 0. Now we'll do middle term breaking. We need to get 52. So 52 is basically 13 into 4. So n square minus 17 we write as 13 plus 4 n plus 52, which is equals to 0. N square minus 13n minus 4n plus 52 is equals to 0. Now this implies n comes common, n minus 13. Here in this 2, minus 4 comes common, n minus 13 equals to 0, which implies n minus 13, n minus 4 equals to 0, which implies n is equals to 4 or 13. So n can be 4 or 13. So both values of n is possible because both of these are natural number. So the number of terms can be either 4 or it can be 13 as well. Example 4. Find the sum of part 1. The first 1000 positive integers and part 2, the first n positive integers. So solution, part 1, let's say we are solving. So here the sum basically given to us is 1. Sum of 1000 terms is equals to 1 plus 2 plus ... plus 1000, the first 1000 positive integers. So this implies we use the formula Sn. Sn is n by 2. We can use now this formula where Sn equals to n by 2, first term plus last term, because we know both the first term and the last term. So 1 plus 1000. So this is equals to, this is 500 into 1001, which is equals to 500,500. So this is our sum of first 1000 positive integers. Now the second part, the first n positive integers, sum till n positive integers will be 1 plus 2 plus dot 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 plus n. So this implies Sn will be equals to n by 2, the first term plus the last term. So which implies Sn equals to n into n plus 1 by 2. So this is how sum till n positive integers. Example 5. Find the sum of first 24 terms of the list of numbers whose nth term is given by an equals to 3 plus 2n. So solution. So an given to us is 3 plus 2n. So a1 will be equals to 3 plus 2, which is 5. a2 equals to 3 plus 2 into 2 to 4 plus 3, 7. a3 equals to 3 plus 2 into 3, 6 plus 3, that is 9, and so on. So list of numbers becomes 5, 7, 9, dot dot dot. So here, see, if we subtract two consecutive integers, 7 minus 5, this is same as 9 minus 7, which is equal, and all these are equal to value 2. So therefore D, the common difference, will be equals to 2. Hence it forms an AP. Since there is a common difference over here, the difference of the terms is a constant. So we say that hence the list of numbers form an AP. So now what we need to do is we need to find the sum till 24 terms. So S24 equals to n, that is 24 by 2, a plus 2a plus n minus 1 into d. So this will be equals to 12 into 2 into a. A is our first term is 5 plus n is 24 minus 1, that is 23, into the value of d is 2. So this is equals to 12 into 10 plus this becomes 46. So 12 into 56. So 56 into 12. This is 112, 56, 672. So this value is 672. The sum of first 24 terms of whose nth term is 3 plus 2n becomes 672. Next example. A manufacturer of TV sets produced 600 sets in the third year and 700 sets in the 7th year. Assuming that the production increases uniformly by a fixed number every year, find part 1, the production in first year, part 2, the production in the 10th year, and part 3, the total production in first 7 years. So solution part 1. So since it's given in the question that the production increases uniformly by a fixed number, since the production increases uniformly by a fixed number, every year, therefore the number of TV manufacturers, number of TV sets manufactured in first, second, third years, comma, dot 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 years, form an AP So let us denote TV sets manufactured in nth year by AN. So it's given that in the third year it is 600. So according to question, so therefore A3 equals to 600, which implies A plus 3 minus 1 into D equals to 600. A plus 2D equals to 600. And the 7th year 700. So A7 equals to 700 sets, which implies A plus 7 minus 1 into D equals to 700. This implies A plus 6D equals to 700, which implies, okay, so now we mark this as equation 1, this is equation 2. We are subtracting 2 minus 1. By subtracting 2 minus 1 we get A plus 6D equals to 700 and A plus 2D equals to 600. On subtracting these two equations, the signs change, plus becomes minus, plus becomes minus, plus becomes minus. So A minus A cancels off, 60 minus 2D is 4D equals to 700 minus 600 is 100. So this implies D equals to 100 by 4, that is equals to 25. So therefore, substituting value of T in equation 1, A plus 2 into 25 equals to 600, which implies A plus 50 equals to 600, which implies A is equals to 600 minus 50. This implies the TV sets produced in the first year is 550. Now we need to find, for the second part, we need to find the production in 10th year. So for the second part, what we are going to do is we are going to find A10, that is equals to A plus 10 minus 1 into D. So A just now we found is 550 plus 9 into D we found earlier that it is 25. So this is equals to 550 plus 25 into 9 is 225, which is equals to 775 sets. So this is the number of sets produced in the 10th year. And for the third part, what we need to find is the number of total production in the first 7 years. So we need to find the sum of all the sets that has been produced in the first 7 years, which is equals to 7 by 2, 2A plus 7 minus 1 into D, which is equals to 7 by 2. 2 into A is 550 plus 6 into D is 25, which is equals to 7 by 2. This is 1100 plus 25 into 6 is 150. So 7 by 2 into 1250. This cancels off 625. 625 into 7 we get as 7535. 7 2 14 plus 3 17, 7 6 42 plus 1 43. So this is 4375. So this is the number of TV sets that is produced in the first 7 years. See, in the question it was given the total production in the first 7 years. So we need to add the TVs produced in the first year, second year, third year, fourth, fifth, sixth and seventh. So we found the sum till 7 years. So with this we come to the end of today's lecture. Thank you.